And so my next step is going to be creation of this source file. To do this, what I will do, I will just jump to my source folder where I already have main CPP and serial date CPP, and simply right here go and say new text document, and say that this is going to be serial date.h, the header file, right? So H stands for the header file. By the way, a reminder that the header files, the idea of the header file is that the header file include normally appears at the top of the source file. That's why it was given originally the name the header file. I will split my view right now, so I have two panels to work with, and now I can just simply drag and drop it right here. Hopefully it'll open in the editor. Very good, it opens. And for now I will close my Solution Explorer. I don't need it right now, but given all the setup that I have so far, so we have the serial date, and this is the corresponding header file. So once again, it would probably be a good idea to add the name of the file right at the top of the file, so we can recognize what kind of file this is. And of course, we begin our work with adding the header guards to this header file, which every header file should include. So normally I just copy and paste the name of the file, replace the period with underscore, and say included, which makes it look a little ugly. Then I highlight everything, press Shift Control U to convert it to uppercase, and this is the beginning of my header guard. And then I say if it's not defined, then define it like this. And at the end, the syntax requires us to also say and if. And I typically also add a comment that corresponds to the name of the header guard. So with this respect, everything that we do is supposed to be happening right here within the header guards. And that includes the other includes that we might want to use. So what should go into this header file? From here, remember, we started with a bunch of function declarations. So now once I have this, function declarations or function prototypes are now part of this header file. So now having this CPP file, the source file, part of my project, and this is now, if I show you again, Solution Explorer, this file is now staying side by side with main.cpp, so it's part of our application. So all of these functions are now part of our application. And we also have the header file that we can include anywhere else. For instance, if we want to include this in our main file, we just include it right here as just using the name and saying include and using quotes to include this file, and it should be all fine. So let's just for to make sure that everything is correct, build this, and you see that it says that it's building fine, which is good. Now let's continue on with our view. Let's switch to the view to our presentation, and here's an idea that we can try to explore a little bit more. Right. So remember, we want numeric representation of our dates as an example of object. So we can take this example. I'll just copy and paste this and paste it in main, so I can continue my presentation with simply using our source. And Given that I added this include file, now I pretend that my conversions work very good, and I'll set my month to December 31st, 2019, right here, right? Pretending that my functions work good and they're all done. So here's the call to serial Julian date. So the idea to call this function and be able to convert three integers that represent month, day, and year to a single integer. Okay, and I call this integer serial date. And now the good thing is that because it's a serial date, it's just an integer. And therefore, it allows all sorts of manipulations that are available to integers. For instance, I can add 100 days to it. And so therefore, just by doing this, I just advanced my date, which is December 31st, to 100 days forward, whatever happens to be that calendar date. To be able to find out what that calendar date is, we now take our modified serial date and we call function serial to month, serial to day, serial to year, and we recover month, day, and year back, and supposedly we will be able to do the right thing if all of these functions were implemented correctly, like we did in our homework. And then obviously this demonstrates a much better level and much higher level of control over dates in general, because these are the facilities that we can now use: convert to serial date, and then take the result and convert back to month, day, and year. And to an extent, that solves a lot of problems that we have, or we may need to be able to solve regarding the dates. Let's just see how this all works. I'm going to build this and run it by pressing Control F5. You can see, can you see the date that got printed over here? Right? Okay, very good. So I realized that I'm actually not just recording a single Visual Studio application, but I'm recording the entire screen, which is fine. Okay, so of course, plus 100 did not do much in my situation, because my functions are simply hard-coded to return December 31st, 2019. And that's exactly the way it works. But it does demonstrate the concept. So what else can be improved? So let's switch back to our presentation right here and continue on and say, what we did so far is what's called procedural approach. Basically, we have the data, we organize them as integers. We have month, day, and year, we have the serial date concept. They're all integers. We know how to do math with integers, and we're using functions to encapsulate all the computations. So this is all a step in the right direction in terms of handling dates in our example, right? So we replace the original terrible hard coding of dates like this with integer representation. And this basically demonstrates what we can do with this new representation, which is now based on integer, which is very friendly data type for our CPU inside of our computational devices. Now, what could be sort of like named as potential problems with procedural approach? Too many small steps. And these small steps begin with the fact that we need to add 4 different integers to our program, and we need to keep track of all of them. And what happens if we need to keep doing things to them outside of the just one single main function? Somehow we need to find a way to share this and pass this around to other places in the code. So obviously we need to pay attention what can be done better. How can we do things to improve handling of individual pieces? Another considerable setback is that we don't have protection of any kind to prohibit illegal date modifications. If we allow these dates exist in global scope, in the scope of our entire application, there is no protection for setting incorrect, not really deliberately, but by mistake, by making making incorrect decisions in the code. We can obviously set them to look like February 31st, which is incorrect. We know that that should be restricted and that should not be correct. So those are obvious problems that would be nice to be able to address in our application.